Here we go. Okay. And anybody else that's on, if you've got your video on, if you would cut that off, it'll just help with the recording that we put up on our YouTube channel. But my name is Jamie McCutchen. I am with Rymar Waterworks. I'm sorry, my camera's a little off this morning. We're getting ready to start our webinar for May. All right. Got a couple of things popping up on here, so yeah. And cut that off. All right. So this month we're going to focus on South Carolina, Georgia, and Tennessee. And just do those state standards. We'll also talk about a few other things. So we'll do a quick introduction to skimmers or floating outlets. Again, go over basics of skimmer basin design for South Carolina, Georgia, and Tennessee this month. If you have any other questions about specific states, feel free to ask. Then we're going to talk about using skimmers for post-construction, some advanced skimmer modeling and HydroFlow, and then also to wrap up, talk about the new Rymar water quality filter and what you can do with it. Um, so real quick, got a little poll kind of just start off to let me know what kind of familiarity our audience has with skimmers. So if you could just answer that quickly, if they're new, if you're somewhat familiar, or if you use them a lot. So. All right. So in that looks like a good mix of new. So glad to have you here. And then also some that are somewhat, and then a couple that are pretty familiar. Hopefully we'll teach you something today as well. So I do have one or two people that have their video on. If you wouldn't mind cutting your video off, I think it would help with the recording here. So there we go. All right. So for those that are, not as familiar with skimmers, typically we're using ponds without skimmers before. We have some sort of perforated riser with a hole at the bottom, and it's pulling in, discharging water out of the basin from where the sediment concentration is highest. Skimmers have been around for a while now. They meet the requirements to meet surface withdrawal. So they're going to take the water from the top of the basin and let it out first, and let the pond drain slowly, allowing more time for mud to settle and increase the trapping efficiency of the basin. There are a variety of skimmers out there on the market. So the Faircall skimmer was around probably 20, 25 years ago. They were kind of the first commercial brand out. Erosion Supply is kind of similar to Faircloth. You got ours, the Marley float, and the IES. There may be a few others. Seems like there are a couple others coming online now as skimmers are becoming more common. So there's a little quick video just to show you of a skimmer in a basin. This site was actually about 8 acres or so of, oh, what happened? Here we go. About 8 acres disturbed area flow into that basin. And there's the discharge. It was a pretty muddy basin, obviously, when you could see where the skimmer was, but the discharge is pretty clean. This was important because this site was about 100 yards or so from a lake, and we definitely did not want to have a bunch of turbid water going into the lake. So just a quick video to show you the skimmers do work well to do them. So there's 3 fundamentals when we talk about basin design. Number 1 is basin volume. So that's going to be basically the volume required in your basin depending on the area draining to it. So what we generally see in regulations is 1,800 or 3,600 cubic feet per acre. So if you're in an area, for example, South Carolina requires 3,600 cubic feet per acre. Let's say you had a 5-acre site. That would be an 18,000 cubic foot required volume. Some other areas also require to have a permanent pool or sediment storage volume. That area is below the invert of your pipe connection to the skimmer. And it's important to not use that volume when you're sizing the skimmer. What you want to use, main thing here is focus on the required volume, not the actual volume to size the skimmer. Once you, the other fundamental is dewatering time. And so, sediment bases work by allowing time for sediment to settle. And, you want to get that sediment to settle to the bottom of the basin. And that time's going to vary depending on your soil type. So what we generally see across regulations is a time frame of 2 to 5 days, with 3 days generally being the kind of target time frame in most areas. Now that does vary from state to state, so it's important for those of you that work in multiple states, make sure you're looking at what that state requirement is. But generally, 3 days is our target time frame. And then once you have those two, you can determine the flow rate. So simply basin volume divided by dewatering time is going to give you that flow rate. And you'll use the minimum dewatering time to determine the maximum flow rate and vice versa. So for our examples, 18,000 cubic foot of required volume, if we drain that in 2 days, we'd be looking at a 9,000 cubic feet per day maximum flow rate, or 3,600 cubic feet per day is our minimum flow rate if we want to drain in 5 days. And so one thing to note is a lower flow rate will often result in a smaller and typically less expensive skimmer. So just keep that in mind when you're selecting the skimmers. This is an example actually pulled off of a set of plans just to show you the difference between using the required volume versus provided volume. So in this case, they had a detention pond. I gave the top length and width and depth. Time to drain, 72 hours. So they had a 3-day time frame. And they specified an 8-inch skimmer. And they actually did specify Marley, which we appreciate. One thing to point out, the sediment storage required, and in this state, the sediment storage actually is the same thing as pond volume. So the required volume was 1,754 cubic yards. The actual volume was 7,478 cubic yards. Well, if they based the skimmer size off the required volume, it would actually need a 3-inch skimmer with a 2.5-inch orifice, which would be $1,100 product, retail if you're looking at one of our Marley floats. However, if they based it off the provided storage, which was much larger, then it jumped up to an 8-inch skimmer with a 6.5-inch orifice, which was nearly $6,000. So almost a $4,000, $4,700, $4,800 difference in cost between that. The other thing is that skimmer would drain the required volume in less than 9 hours. So we're not meeting our specification requirement to drain that required volume in 72 hours. So we're actually draining that required volume too fast, and it's not allowing time for the sediment to settle completely, before it gets discharged. So important is really to focus on, use that required volume when you're sizing your skimmer. So one more poll here, get this to pop up. I'd like to know where our folks are located today. So got a few states in here to pick from or others. So if you would just quickly let me know who's on with us today. All right. So we've got a good variety. We've got North Carolina, Virginia, South Carolina, no one from Georgia, Ohio, Indiana, Texas, and a bunch of others. So those that are doing other, if you want to put in the chat where you're from, we can, I'll see if I can touch on any specific state location requirements there too. So, all right. So touch on a couple of state specifics. So let's talk about South Carolina first. So South Carolina, and most states require an 80% trapping efficiency. That's what we're shooting for, is getting 80% of sediment out. Appreciate all those that have added to chat. Good to have folks from Pennsylvania here. I know Pennsylvania skimmers are very common, and glad you're on with us. So back here in South Carolina, you're going to use a discharge capacity going to be based on a 10-year, 24-hour storm event. And again, they call it sediment storage. It's really pond volume. It's 3,600 cubic feet per acre. for whatever's draining to the basin. And again, have that 2 to 5 day time frame. One thing to point out in South Carolina, when you do select the skimmer size, they note that orifice size and associated flow rates are product specific and should be based off product specific testing. We'll talk about that, why that's important a little bit here, just to kind of give you some examples of that. But one thing to know that, they don't really want to base it just off an orifice equation. So Georgia, don't have anybody on there specifically from Georgia today, but maybe have some folks that work in Georgia. They also have that similar requirement that each product and each product size has unique design hydraulics. And so they also want to be based off product specific testing versus orifice equation. Georgia requires this little chart to go on the plans. One thing we recommend in this chart is that when you do a time to drain, you put in a range of time, 48 to 72 hour range is what we recommend. Georgia does not have a time frame for dewatering time specified, so it's really up to the engineer, whatever you want to use. But we do, instead of doing an exact, say exactly 72 hours or exactly 56 hours, whatever you may prefer, we recommend that you put in, you at least give yourself a 48-hour range there. And then Georgia also has this design sheet. So you calculate that required storage volume is 67 cubic yards per acre or 1,800 cubic feet per acre. You've got to determine your clean out volume. Clean out elevation. And I'm not going to go through the rest of the chart here because we're kind of focused on just the sediment basin skimmer design here, but all that's pretty standard information. Tennessee, they also require 3,600 cubic feet per acre. However, Tennessee is one of those states that says, okay, we want half of this volume to be wet storage. So basically it's below the invert of your skimmer, and the other half is dry storage. So really you're only draining, you're sizing the skimmer based on the 1,800 cubic feet per acre is what you want to do. That is that required volume for the skimmer. And you wanted to make sure the dry storage is to be watered down to the permanent pool in 72 hours. Now, there's been some question, is that a minimum or maximum? Because sometimes it's hard to hit exactly 72. In talking to folks in Tennessee, I understand that is a maximum time frame. They want the pond to drain down in 72 hours, so it's got room for the next storm event that may come around, especially, we're coming up on summertime thunderstorms. So they want to have that. So generally, they said, a time frame of 48 to 72 hours is what they would like to shoot for. Tennessee has some standard details that do include the skimmer there. They show, because they have that permanent pool, they show a rock pad for the skimmer to rest on. And one thing to note is skimmers are gravity flow. And so when the skimmer gets down to the invert, they're going to stop draining. So not necessary to have that pad to keep it from draining the pond. This little quick chart just to kind of compare to show you how different states do vary. So again, South Carolina's 3,600 cubic feet per acre based on the total area. Georgia's 1,800 cubic feet. Tennessee's got that, 1,800 cubic feet of dry plus 1,800 cubic feet of wet. And I included Indiana in here just because Indiana has the highest requirement of 5,600 cubic feet per acre plus an additional 1,000 cubic feet per acre disturbed area sediment storage. Now, Indiana does allow you to calculate it based on a 2-year, 24-hour storm event. And so if space is an issue and you need to try to reduce the size of the pond, it may be worth running the numbers to see if it's if that 2-year storm will generate more or less than 5,600 cubic feet per acre runoff. Surface area, there's a couple of equations out there. They generally come out about the same. You basically just want to make sure you've got surface area provided. Some areas don't do surface area. They just have a preferred or maximum depth. Principal spillway, that's going to be your skimmer and riser. So typically either 2-year or 10-year design storm is what they're looking for there. And then emergency spillway can vary anywhere from 10-year to 100-year storm. Where skimmers are required, basically the way this works is if you've got a riser structure in your pond, they want a skimmer. South Carolina technically is 10 acres or more, as well as Tennessee. Georgia is preferred. Most MS4s now require it. And then Indiana, basically any sediment basin, again, if it's a sediment trap with a rock outlet, then you wouldn't have a skimmer. But any basin that's got a outlet structure would need a skimmer. And then dewatering time, again, 2 to 5 days is kind of what we see in most places. Georgia doesn't have a standard. Tennessee, I say 1 to 3 days. We really kind of shoot for 2 to 3 days. And then Indiana's that 2 to 3 day time frame as well. So here's a little chart that kind of explains why these states are now requiring the skimmers based on testing rather than orifice equations. So this is a test that TRI Environmental did for Georgia when they were helping rewrite the Green Book. And they tested 3 different 3-inch skimmers. 2 of them, and our test tank is 1 foot to 4 feet deep. 2 of them were pretty similar. They started off at 37 GPM. One of them was nearly double at 70. And as the depth in the tank increased from 1 foot to 4 feet, all 3 skimmers had an increase in flow rate of about 25%, where the two of the 3-inch skimmers were pretty close, right around 50 GPM. And again, one of them was nearly double at 90 GPM. So the important thing here is recognize that all those skimmers are constant head. They're not really constant flow. There's just a variety of things in the design of the and setup of the skimmer that affect that. And that, if you just specified a 3-inch skimmer and didn't give any other information, and you intended to have one that drained at 37 to 50, and you got one installed, that's draining out much faster, then it's going to take too long. I mean, it's going to drain too fast. And vice versa, if you intended to have the higher flow rate, you got a slower one, it's going to take too long to drain the pond. So just important to include flow rate when you're specifying the skimmers and not just skimmer size. So we have a tool that's available on our website. We actually have what we call an engineer's pack that has all of our details and tools in one download for you. But it's a simple Excel tool. So in the top here, you can put in your site information, basin description. We give you 2 places for other information. Sometimes there may be a phase 1, phase 2 change or just whatever, just someplace to plug that in. We have this check up here, and this really came from comments from MS4s and state reviewers that the most common error that they see engineers do is base the skimmer size on the total volume of the pond, not just the required volume. And so we've got a check. So you can plug in your acre and your cubic feet per acre required to come up with that required dewatering volume. Then you're going to put in here your minimum and maximum time to drain. Again, that's 2 to 5 days, but you can adjust that as needed. Pond depth. Now this is important. Make sure you put in the pond depth needed to achieve this required volume, not your total pond depth. If your pond's going to be a post-construction basin, it may be 8 or 10, 12 feet deep, but you may only need 2 or 3 feet to meet your required volume. Top length and width and bottom length and width. I know there's almost no perfectly square or rectangular basins out there, so use your engineering judgment and adjust those numbers. We recommend you try to get this calculated volume within about 5% of your required volume. Don't spend all day, 120.25 and 50.31 or whatever in order to try to get that exact. We've got a pretty big range of time to drain here. So a couple of, 100 cubic feet is not going to make a huge difference. So, but once you plug that in, if you go down to the bottom of the Excel sheet, there's a skimmer report page tab, and it's going to print out a nice, neat 8.5 by 11 that you can use for it. The top section is going to have all the information you put in. Again, have this check right here that's really easy for the reviewer to see. It's going to tell you that minimum flow rate for the maximum time, maximum flow rate for the minimum time. And then because it is our tool, it's going to tell you which of our skimmers fit within that range of time. So in this case, you can go anywhere from a 2-inch with a 1.5-inch orifice to drain just under 5 days to a 4-inch with a 2-inch orifice to drain right at 2 days. In this case, I'd probably pick our 2-inch with a 2-inch orifice, which would drain in just under 3 days, which is a good target time frame for most ponds. So, and that's also going to give the least expensive of the skimmers for your contractor. So in addition to the design tool, we have several details on our website. So this was for basically a temporary basin. So it would have just a pipe through the dam. It wouldn't have a riser structure, and this would be a dry pond. This would be more typical with a riser structure here. This one detail is more with the permanent pool. And so you're going to have this chart here. And these are available again in CAD and PDF, so very easy to edit as needed. But you're going to put your criteria for all your basins on the site. Again, many sites may have 2, or some of these solar sites have 20 or 30 basins on them. So got your minimum length to width ratio, maximum length to width ratio. Again, this is for basin with a permanent pool, so it's got that sediment storage volume required, what your dewatering volume is, surface area requirement, if that's a thing. And then here's where you set your minimum and maximum time. And then in this case, you've then got data block in here that you can plug in information for multiple basins on the site. That sediment storage, dewatering volume, drainage area, disturbed area, your flow rate, the basin surface area. Again, just making sure you're meeting the required bottom of the basin, outlet, invert pipe, riser, spillway width. Then over here, you get to your skimmer size, your skimmer orifice diameter, the skimmer type. Now, it is our details. We plugged in Marley for you, but you can edit that if needed. Is an equal allowed? Typically, that's yes. There may be some situations where that's no, but we recognize most of the time that's going to be, contractors can use an approved equal. And here's where you're going to set your minimum and maximum flow rate. So if you set that on the front end, number one, your reviewer has approved that range of time. And so if your contractor does want to change out skimmers for some reason, then you can, don't have to hit that exact flow rate. You've got a range to work with. And then also it's very easy to determine if that skimmer they want to use, falls within that minimum and maximum flow rate. This is our detail for our skimmers. So we do have a chart here at the top that includes the flow rate for each skimmer with each orifice configuration. And it gives you at a depth of 0.1, 0.3, then a half a foot up to 4 feet deep. One thing about our skimmers is we have an orifice plate that we use. Some other skimmers have little discs that you cut to a specific size to adjust that orifice size. We don't do that. We just give you 4 or 5 different orifice sizes within each skimmer. Honestly, it was made it a lot easier to test those, so just based on those 4 or 5. So you're going to pick one of those that is going to discharge your basin within that time frame allowed. The number one question we get asked is, how long does the pipe need to be between the riser structure and the skimmer? We recommend 1.4 times the height of your riser structure, but also a minimum of 8 feet. Sometimes we can go down to 6 feet, but you want the skimmer to kind of sit out in the pond just a little bit. The other thing we do, if it's a dry basin, we recommend a depression, and that's just to help the basin drain completely, which we'll show a photo of that in a minute. The newest thing we have is our Marley Float skimmer calculator on our website. And so this is designed to give you just a quick, easy way to do it. So you got your basin name, you plug in, whatever it may be, A, B, C, or whatever it may be for your site. What is that required pond volume? And what is the minimum and maximum time to drain? When you do that, we'll calculate the minimum max peak flow rate for you. And then it'll tell you which skimmers meet, drain that required volume within that time frame, what the drawdown time is for each one of the options that may work. And then whichever one you prefer, you hit the download button, and it'll pop up a nice, neat PDF that you can download. Has all the information already plugged in for you. It's more of a generic detail for all the skimmers, but it gives you that skimmer size, orifice diameter, the drawdown time in days, what that flow rate is for that skimmer, the required pond volume, and the minimum max time to drain. So, based on that, you can determine that min and max flow rate that will be allowed. And, if a equal skimmer wants to be used, they can. So this photo shows why we recommend the depression at the skimmer. So this pond, obviously a new pond, they tracked in the sides, they've got their baffle in, look, they did a pretty good job constructing it, but you can tell that as soon as they graded it, they came in and put in the stone pad. And what that did is it raises the skimmer up off the bottom of the pond, maybe 8 inches or so. So because it has that, this pond's always going to hold, 6, 8 inches of water until it either infiltrates or evaporates. If it's intended to be a dry pond, you want to get the skimmer to sit down as much as it can so that the pond will drain as completely as it can. Contractors don't always install skimmers correctly. This is probably one of the worst installs we've seen. An inspector sent us this photo. I'm not even sure how they attached it here to the outlet structure, and obviously the pipe's way too short, but they left this valve open anyway, so the skimmer's really not doing anything. For some reason, the contractor installed this one upside down, but they put almost no pipe here, so it's not going to float up very high anyway. It's kind of hard to believe they did that because there's a sticker on the top of the skimmer that says this side up and has a QR code that goes to an installation video. So, we try to make it as easy as we can for contractors to get it installed correctly. And then skimmers are not maintenance free. This is one that actually had vegetation growing out of the skimmer. So this pond would never drain. And the reason was there was a big root ball inside the skimmer, basically blocking it up. So this pond was all, obviously in need of some additional maintenance as well. So that kind of wraps up our basic sediment basin design side. If anyone has any questions, feel free to put it in the chat or you can unmute and ask. And now we're going to jump into talking about permanent use of skimmers. So again, we're going to add another quick poll here. Just so, have you ever considered using a skimmer for permanent use? So if you could, if you're on, if you can let me know if anybody out there is, well, see if you have considered it. I got one that's a yes, always, well, actually 2 yeses now. That's awesome. 3 yeses. That means we're hopefully having some benefits. I'm going to launch that, share those. So most of you are no. So, over 60% said no, haven't considered. So hopefully this next part will at least get it in mind. Several have said it's considered and 3 have said they have. So that's great. So let's talk about why you might want to consider using a skimmer permanently. So your typical dry, we're going to focus on dry basins. If it's a wet basin, obviously it's a little bit different, but dry basins are the most common BMP. And what happens when you're converting that pond to a post-construction, you're going to remove the skimmer. You're going to put in some sort of a low flow orifice installed typically at the bottom of the basin to release that first flush. This is assuming you're doing water quality. And you're going to have to do something to try to, include some sort of guard or filter to reduce clogging. But, the whole point of water quality in dry basins is, hold that volume to give time for sediment or other pollutants to settle to the bottom. But then we settle everything to the bottom and then we discharge it from the bottom. So just like we used to do with sediment basins, we're discharging from where the pollution level is the highest. So we all know that, the sediment's going to settle, based on the size of the particle. A lot of times you're going to have it, a 4-bay is going to capture the big stuff. But, if you looked at the water column across a basin, it would look something like this. Where it comes in, it's going to stay dirty basically the entire way. But then as it gets to the outlet, that top level is going to be cleaner than the bottom. And so, since basins rely upon the natural settling of sediment particles as they travel from the inlet to the outlet, and the skimmers release the cleaner water from the surface, which has been widely accepted for construction, and it's proven to be a very cost-effective way to increase trapping, it just makes sense to consider using the same methods for post-construction water quality. And so, you're going to have that benefit of that cleaner water being discharged and more time for the sediment to settle. So this is a site where we retrofit a pond with a skimmer. This was basically due to maintenance. So it had a 2-inch low flow orifice in place. And we went back in and retrofit the pond with a 5-inch skimmer. Now this pond, the current bottom of this pond, or that 2-inch orifice, was 6 feet below what is now the current bottom. So the pond had been neglected for a long time and not well maintained. And the main thing was that 2-inch orifice had clogged up. And, because it was the enforcement for maintenance was not happening, it went on this way for maybe 20 years or so. So we were able to redesign the basin. You can see we closed up these old orifice holes here, added some new ones, but replaced that 2-inch orifice with a 5-inch skimmer. About a year later, they were doing maintenance on this pond, and they had cut all the vegetation but hadn't gotten it out of the pond. They had a huge rain event of about 5 inches in just a few hours, and it washed all the debris down to the bottom of the basin. But you see the skimmer sitting there was able to still drain the pond down with that. You can imagine if that was a 2-inch orifice and had been clogged, and it's kind of hard to tell in this photo, but that riser is about 12 feet tall. So these next orifices are up here around 8 or 9 feet above the bottom of the pond. So just getting to that orifice would be one, very difficult, if not dangerous, to try to get it unclogged. So just from a maintenance standpoint, skimmers are great to consider for post-construction, and you're getting that enhanced water quality because you're releasing that water from the near the surface. So if you're going to do that, you need to know how to model it. HydroFlow seems to be the most common software, especially now that it's built into Civil 3D. So we'll go through a little quick example on how you would model a skimmer in HydroFlow. So this was a site that's actually in a MS4 that required quantity control during construction. So it was about a 5 acre, 5.5 acre area, about 2.25 is being disturbed, going to a little sediment basin and then discharging out. And so pre-development, again, about 5.5 acres, curve number of 59. It was a wooded site, type B soils, class B soils. Time of concentration was about 20 minutes. Post-development, the portion that was being disturbed was about 2.25 acres. The other 3 acres, 3.25 acres was left undisturbed. So the criteria was the same as pre. Curve number of 86, that was a bare earth disturbed condition. Time of concentration down to 7 minutes. So when you're building your basin, what you want to do is you want to build in a stage to be able to enter in the flow rate. So in this case, we built in 0, 0.1, 0.3, 0.5, and every half a foot up to 4 feet. This pond just happened to be 4 feet deep, so it just worked out well there. Again, we give you the flow rate on the detail for that. And so then when you build in your outlet, you got your barrel pipe going out. In this case, it was an 18-inch pipe going out. It had a 6-inch orifice about 1.75 feet above the bottom of the basin, had a riser structure and a rectangular weir at the top of the riser structure. And then kind of the secret sauce here is the user-defined column. So this is where we plug in manually the flow rate. Because we built in those stages, when we built our basin, it gives us the data points, 0.1, 0.3, 0.5, to fill in that flow rate here. Now, if your pond's over 4 feet deep, there's a couple of different things you can do. If it's just a little, say if it's 5 or 6 feet deep, you can either kind of hold that last flow rate at 4 feet. You can extrapolate based on the last couple of data points. If it's much deeper, say if it's an 8 foot or deeper pond, you can go back to our design tool that we showed you before, plug in a pond depth of, in this case, say 8 feet, but it could be whatever that actual pond depth is. And the tool is going to break the water level down into 20 different increments, and it's going to give you the flow rate at each increment there. So you can kind of break that down, maybe pick one at half a foot or foot intervals to plug in. This is our 2-inch with a 1/2 inch orifice, so you're not seeing much change in flow rate, but the bigger skimmers, you're going to see a much more variation in flow rate from that 8-foot depth. And so that's a good way to calculate that flow rate at whatever depth you have. Yeah, so again, just break it up in 20 increments and you got the flow rate at each increment there. And so then if you look at a schematic in HydroFlow, typically you would have a low flow orifice down here. You don't have that because you use that user defined, but there's our 6-inch orifice, our weir, and our riser. But if you look at the stage discharge curve, this is the flow from the skimmer. So the skimmer flow is kicked in, that user defined flow is here. Very small amount of flow compared to the total flow of the pond, but that way the user defined is working properly. Any questions on HydroFlow? I will mention, I'll talk about this at the end, but we have some training series on our website that goes a little slower, more detail into that. So easy to find if you need to kind of go back and look back on some of the HydroFlow issues. So last thing we're talking about today is advanced skimmer modeling and filtration-based water quality. So in most cases, water quality is done volume-based, right? You take that first flush volume, hold it for 24, 48 hours, and the intent is to allow sediment to settle. Filtration-based, we developed a filter that goes around our skimmer. And so the idea here is that the filter is 3 feet deep or hangs down 3 feet. And so it's going to filter out the top 3 feet. So the skimmer is going to pull water through the filter, and it's going to go through the filter before it gets to the skimmer to get discharged. If it's over 3 feet, we're going to allow gravity to do the job there, right? You still got sediment's going to settle. There's not enough turbulent force to pull those sediment particles back up to the skimmer. So the bottom of the filter is open. Now, if it's sitting on the ground or, until the pond reaches 3 feet of depth, everything's got to go through the filter. But once it comes up, higher in the pond, water can come underneath, but it's going to just, let gravity do the work to keep those sediment particles down. So going back to that pond we showed before where we had retrofitted, we used that pond for R&D for several years now. This was a prototype of the two-stage filter we came up with. So it was basically a turbidity curtain with, allowed flow. So there was a polyethylene screen material within the turbidity curtain. And then it had this inner fabric here, which was a non-woven that was actually put in 2 layers with slits in it. And so what we tried to do is we tried to create water flowing, kind of weaving through there to create more contact time with that material. We've had that prototype in the pond for a little over 2 years. And you can see here this photo, the turbidity of the water outside the filter versus inside is substantially different. This is the actual outflow. Pretty clean water coming out. Now, definitely wouldn't drink it, coming out of this pond is pretty nasty, but, considering what's coming in, what's being discharged after going through there, much cleaner water going out. And so we felt like we had a good product and we decided to have it tested. We did third-party testing. TRI Environmental did that. And they confirmed we're getting over 90% TSS removal with this skimmer filter system. A couple of things about the testing. Again, TRI Environmental, well-respected firm, has done a lot of work for Georgia and other states. Did this. There is now an ASTM standard for sediment retention devices. It's ASTM C1746. And so it establishes your soil gradation, all the criteria for testing. So a lot of people are not familiar with ASTM standards for stormwater, although they're fairly new. But there's something ASTM is now working on, establishing even more standards for other stormwater related items. So one thing to point out when we did this testing, a typical pond has a forebay, has travel distance, may have some vegetation, has a variety of things that are going to affect what that sediment trapping really is for the pond. Well, we didn't really know how to figure out what percentage would come from a forebay, what percentage come from the travel distance, what percentage would come from the filter and skimmer and surface withdrawal. So what we did is we took out the forebay and the travel distance. So you'll see here on the right side, this is where sediment-laden water is being entered into the tank. The tank was set up to simulate a dry pond. So we started off dry, filled up, ran for a period of time, drained back down. And we had to do 2 different tests of that. And both of those tests got over 90% TSS removal. So now this is that same pond, kind of gives you a better view of what that pond looks like. This pond is in a watershed. It's probably got 40 or 50 acres draining to it. And it's older commercial development that essentially has no other stormwater management in place. And so we get a lot of junk and debris in this thing, which is why, when it clogged up, it had built up so much. But we've now installed the permanent version or a commercial version there, and we're monitoring it. We've got a time-lapse camera set up. And so we're going to make sure it functions properly. And it's been down there for about 1.5 years now. We're going to keep it out there for probably 3 or 4 years just to kind of see when it does start to deteriorate. So this is a little quick time-lapse video. A lot of it's at night, so it's a little hard to see. But you can see here, this is that pond. Had a big storm, so the pond's filling up pretty quick. Gets up to the next orifices, then the skimmer starts to drain it down. It's draining pretty slowly, which was the intent. And this pond's still designed to release that first flush over 24 hours. Rained a little bit more over the night, so it filled back up some. And then again, most of the videos occurring at night, so a little harder to see. But then daybreak comes along, we still see a lot of debris in this pond, but the skimmer's doing its job and draining the pond down slowly. Again, over roughly 24 hours or so to release the first flush volume. So what are some benefits to using filtration instead of settling, or volume? So number one is your pond's going to provide a large containment volume, and it's going to reduce the maintenance frequency and help treat larger drainage areas. There's also excellent potential to retrofit older basins that did not include water quality benefits if you can maintain the peak flow rates for each of your storm events. So what I'm saying is if you, let's say you have a redevelopment site, maybe you're going back in one of these commercial areas that didn't have stormwater management in place, or maybe it had a pond in place that didn't include water quality. Well, if you try to retrofit that pond to incorporate a first flush design for water quality, it's going to greatly increase the volume required in that pond, and it's probably not going to work. Most ponds don't have excess volume in them. So, but if you can maintain those peak flow rates by using a filtration instead of settling, then you can retrofit those ponds to provide water quality. And then, filters of ponds can be relatively easy to access and maintain, especially when compared to systems that use underground vaults or require confined space entry. Again, you can base the peak rate of discharge on your filter treatment flow rate up to whatever that first quantity storm event is. So in most cases, that's a 2-year storm. And so, if you're not required to slow down storm events up to that 2-year, you can set your peak flow rate out for basically, your lower storms at that 2-year discharge rate. The filter is going to treat 100% of the runoff from the storms up to the peak rate of the filter. So what we're saying there is when you base water quality off that traditional first flush, that's based off typically an inch or inch and a half of runoff from the area draining to the pond. Well, that's typically equivalent to maybe a 2-inch or 2.5-inch rainfall event. Well, what happens when we get a 1/4 inch of rain in an hour or two, right? You get very little ponding. So if you're not getting the ponding, you're getting very little treatment as well. So, and then other thing here is your filtration media can be customized to target specific pollutants of concern. So one of the materials we use is designed to absorb hydrocarbons. It also has some tests to see how it helps with metals. If you've got other pollutants of concern, you may be able to find a media that you can be added to your filter to target that specific pollutant. So that's kind of the benefits of using filter. But if we take it a step further and we use a skimmer with the filter, how can that be beneficial? Well, one, now you've got a flow control device. Your skimmer can be used to control that peak rate for the lower storm events. So again, if you can select a skimmer that maybe can handle that 2-year storm rate, then that skimmer is going to be your flow control for your 2-year storm event. The skimmer is going to increase your filter efficiency by withdrawing from the surface where the water is cleaner. So, if we use that, outlet at the bottom of the pond and say wrapped it in some sort of a filter, then that filter is going to get clogged up very quickly because that's where all the sediment is going to accumulate. But if you've got the filter attached to the skimmer where it floats up and down, now you're trying to treat this cleaner water. And so your filter is not having to work so hard. So it's going to increase the life of that filter and reduce the maintenance for the filter. And then again, the skimmer is pretty easy to access. You just, typically have a rope tied to it. So you just pull it over to the side of the pond, or if it's a dry basin, just let it drain down. You can get out to it to maintain the filter or change the filter. So there are some challenges to using skimmers with filtration. So number one, filters are prone to clog over time and will require maintenance and periodic cleaning or changing. Right now, we're recommending change out the filter every 2 years. That's based on how long the prototype was in our test pond and it was still functioning after 2 years. So we're comfortable with it last at least 2. Your skimmer's got to be durable and last more than a few years to be suitable for permanent use. Our skimmers are HDPE. There's some other skimmers that are now coming along that are more designed for permanent use. So that idea is kind of catching on now. The biggest challenge we have is there are no established standards for basis of design and permitting based upon a combination of a pond and filter. So if you go to pretty much any design manual out there, that's a MS4 or state manual, you're probably not going to see a filter in a pond as one of the standards. So, you're just going to have to use either, proprietary device standards, or sometimes it's called MTD device standards, or talk to that reviewer and see if they're willing to consider it. I feel like most MS4s now are open to better technology. to, if they see a benefit for their watershed. So one of the things on here, this little quick example of how Georgia does this. So Georgia has the Stormwater Quality Site Development Review tool. And so you put in your pre and post area. So in this case, we had 5 acres of woods and grass and 2 acres of pasture, and that's going to 5 acres of impervious and 2 acres of open space. They have a standard runoff reduction and effective TSS removal for a variety of their standard BMPs. So got a whole bunch of these BMPs that you can look at. And then down here at the bottom, we added the Rymar water quality filter. Now, our testing has shown 90% TSS. And again, that's to an ASTM standard. Georgia has said they would, they would like to see some additional testing on that before they give us the full 90%. But they've been very comfortable allowing 50%. And so what we did is we plugged in 50% for the filter, but you also get 60% for a dry basin. So if you combine the 60% dry basin and then the 50% for the filter, the way their tool works, you achieve 80% TSS removal, which is the standard you're trying to achieve. So you've got, basically in sequence, you got a dry detention basin along with the Rymar water quality filter. And we've got several MS4s in Georgia have accepted that now and said, yes, those two combined meet 80% because the dry detention basin by itself is not meeting that. I know Tennessee, typically a dry detention basin doesn't meet it by itself. So we're seeing some similar results there in Tennessee with that. So kind of wrapping up here, I want to run through kind of a comparison of the traditional volume-based first flush design versus a filtration-based based on the flow of the filter. So our example site here is going to be a 5-acre site. We're going to go from a wooded curve number 55 to a post-development commercial curve number 92. First thing we're going to do is look at our pre-development flow rates. So our 2-year storm based on a 5-acre site, time of concentration of 48 minutes. We're getting a small flow pre-development 2-year storm 0.72 CFS. I've got the 10, 25, and 100 on here, but we're really going to focus on that 2-year storm. So next thing we're going to do is we're going to look at the water quality volume and the post-development flow rates. So, we're going to a 5-acre commercial site. So we're going to assume the time of concentration is down to 10 minutes. In South Carolina, the water quality storm event generates 1 inch of runoff for a dry pond. If you're in Georgia, it's 1.2 inches, 1 inch in Tennessee. It's either an inch, inch and a half in North Carolina. But using trial and error, we determined that a 1.73 inch 24-hour storm would generate that 1 inch of runoff or 18,150 cubic feet. And that's going to equate to a post-development flow rate before we get to the pond of 7.2 CFS. And our 2-year storms jumped up all the way to 19.72 CFS. And most engineers have a spreadsheet that looks something like this to determine that first flush orifice size. And in this case, again, we've got that contributing area of 5 acres. That 1 inch required for a dry pond, 18,150 cubic feet. We want to hold that volume for 24, or not hold it for 24 hours, but drain that volume over 24 hours. And that's going to give us an average flow rate of 0.21 CFS, which based on the average head and flow comes out to a 2.6 inch orifice. So I ran through the model, actually plugged in a 3-inch low flow orifice here. Our hypothetical pond takes 3 feet of depth to generate that 18,150 cubic feet. And then we've got another 3-inch orifice, 3 feet above the bottom, and then an 8-inch orifice at 5 feet, and then you've got your top riser. So ran this through the model and came out with our peak flow rate for our water quality storm at 0.25. Again, we're shooting for 0.21. That's because I went from a 3-inch, from a 2.6 to a 3-inch. Peak elevation is only 12.5, but the volume required is only 10,672, not 18,150, right? That's because our spreadsheet assumes that full water quality volume kind of magically just kind of poof appears in the pond instantaneously, which obviously we know is not the case. It's got a hydrograph inflow and outflow. So actually we only need 10,672 cubic feet for our water quality, but we're required in most areas to have that full water quality volume based on that 1 inch or whatever that 1.2 or 1.5. So 2-year storm event based on this model is going out at 0.81. If you recall, our pre was 0.72. Maybe the reviewer lets you get away with 1/10 of a CFS increase for the 2-year storm, maybe not. It's going to depend on your area. So the alternative here is let's look at how we would use a skimmer to control that peak flow rate. So our peak flow rate for a 2-year storm is 0.72. So the 6-inch skimmer with a 6-inch orifice, the peak flow rate for the skimmer, which is based on a 4-foot depth, is a 0.778 CFS. So let's plug that in. And then this is the detail for the filter. So the filters are designed or sized based on our testing. So what we're doing is based on the flow rate, we're maintaining the area, the square footage, total area of the filter. We're also maintaining the total length of the filter. So whether all the flow goes through the filter, so that's a maximum flow rate, gallons per minute per square foot, or maximum of, let's assume the filter was completely clogged and it was going underneath the filter, we're maintaining both of those variables. So this is the detail for what it would look like in the basin. You may recall earlier our sediment basin details showed the skimmers parallel to the dam. That was just for ease of maintenance. Because some of these filters can get fairly large, we're now showing it more pointing out in the middle of the pond because we don't want the filter to get stuck over on the side of the pond. So now if we run that back through the model, using our 6-inch skimmer here, and we modeled that like we showed you in HydroFlow how to do, the peak flow rate is now 0.7 CFS, and we're only using 7,600 cubic feet of volume. So instead of this 18,150 cubic feet of volume, we only need 7,600 cubic feet, and it's basically a foot of depth in the pond that they were freeing up. Now, because the skimmers also controlling that 2-year storm, that's the only outlet is our 6-inch skimmer for the water quality event and the 2-year, and our flow rate's 0.78, so we're closer to that 0.72. And we got an 8-inch orifice plugged in at basically 4.8 feet above the bottom, which is controlling the 10-year storm. So if you compare that, I'm going to skip that slide and just look at percentages, a little easier to see. But if you look at traditional pond storage versus skimmer, we have a 30% less storage required for the water quality event and 14 and 12% for the other storm events. So in short, you're using a smaller pond and you're treating it to a higher level of TSS removal. So summary here, skimmers are less prone to clog than orifice located at the bottom of the pond. Often we're going to require less maintenance to keep the pond functioning properly. We understand ponds aren't necessarily always the best maintained of things. So having something that's going to help it function better is going to be a good thing. Again, skimmers can be a very effective way to retrofit existing basins to reduce maintenance and provide enhanced water quality. We've seen a number of basins retrofit just for maintenance issues. That skimmer is going to, you're going to have a larger orifice, so it's going to clog less. It's also going to be much easier to get to. And then again, that surface draw is going to release cleaner water from the basin. So you're going to get enhanced water quality even without the filter. But if you add the filter to it, the use of the skimmer with the filter has been tested to confirm 90% TSS removal. The skimmer with the filter treats more of the annual rainfall. Again, in our model we ran, the skimmer and filter are treating all the way up to the 2-year storm event, which is typically a maybe 3.5 to 4-inch rainfall event. It's also going to treat those very small events because everything has to go through the filter before it gets discharged. And we're going to do all that, and we're going to do it with a smaller pond of 15 to 20% over the traditional first flush methods. So one last question here. Now that you're familiar with this and you're aware of the benefits, would you consider skimmer for permanent use? So if you would, do that poll. Most of you are saying maybe. I always have at least one that says no, and that's okay. And we've got, about 30% saying yes, it's a good idea. So we'll end that, share the results. So 20 of the folks answered. Everybody but one said it was at least maybe for the right project, which we agree with. And there's some times where it's not going to be right. If you're in an area, probably the biggest challenge we have is if you're in an area that has frozen conditions. So if you're in, Minnesota, northern Ohio, some of those Indiana areas, northern Indiana, your frozen conditions may prevent that. So, got just a few minutes here. We'll just touch on a few more things. So this is our website. We're very proud of it. We try to keep it, up to date and always kind of making improvements to it. I mentioned before, we have our resources and training page. We always have our latest webinar. So typically, within a day or two, we'll have today's webinar up. And we also have this training series. So we've got 7 different training items on here. So each one of these are broken down to like 10 to 15-minute segments, focusing on specific items. We didn't talk about SEDCAD today. So some of you, if you're in states that use SEDCAD, I have a training series segment on modeling in SEDCAD, modeling HydroFlow, a variety of things. Also go into more detail about modeling the water quality filter. If you go to our design spec cut sheet page, we have our engineer spec pack. You download that as a zip file. It's going to extract into 3 different folders. You're going to have one folder that's got all the skimmer details, the design tools, all of our test data, supporting information you may need to submit. There's going to be another folder with sediment basin details, and then you'll have another folder with the water quality basin details, design guidance, test data, etc. there. So make it very easy for you to organize on your system. Again, our product is an HTP product, so it's always been intended for use for permanent ponds. It's very UV resistant, virtually indestructible. Say that we had a skimmer in Alabama a pond got blown out by a hurricane. They found the skimmer about 100 yards downstream, picked it up, took it back, put it in, it worked fine. So very, very durable product. And it's always been intended to be part of the permanent outlet structure. We have this debris guard around it. So that kind of, if you got any floating debris in the pond, one difference in ours is it takes water from just below the surface. So it's going to tend to not clog. You're not going to have that floating debris get to and clog. And we say it'll work in mild frozen conditions. It'll take 6 inches more ice before you really, start decreasing the flow in the skimmer. Mentioned our orifice plates. This little quick video show how that works. So like I said, all of our skimmers have the orifice plates in them. So you simply rotate it, got a little metal nub here to make sure it's centered. So really easy to change the flow rate. You just rotate the orifice sizes. You're going to have 3 to 5 flow rates in every device, and they've all been third-party tested to verify flow rate and drawdown times. We did redesign the skimmer. This is, can take this video out now, but about 2019, we modified our design, but before it was a little top heavy, and if it wasn't installed correctly, it would lean or tip. It was redesigned in 2019 to make sure it always stays level, floats level in the pond. Our 6 and 8 have handles built into them. They're pretty heavy. Our biggest challenge with these is because we do take water in from below the surface, that outlet pipe is submerged. And so we have to have enough weight to hold that pipe, underwater, but also a big enough flotation to make sure it doesn't sink. We have 6 different models. One thing to point out, we have 2 8-inch models. Our standard 8-inch uses a 6-inch pipe to connect to the outlet structure. Then we have our 8-inch with an 8-inch pipe. We refer to that as our 8-inch max. Point out the flow rate on it is almost 2 CFS, which is just about double what most other skimmers are in the market. So that wraps us up today. I want to thank you for attending. For those of you that need a PDH certificate, if you simply email us at info@rymarwaterworks.com, we'll be glad to get one out for you. For those of you that are in Indiana, we are approved by the state for continuing education credit. If you're in a state that requires approval, let us know. We're glad to work on that. It's sometimes kind of hard to find in what states you got to have approval or not, but this is intended to be a very technical presentation, certainly worthy of continuing education credit. So again, thank you all. Hope you have a great rest of your day. Hope everybody had a great Memorial Day weekend. When we planned this thing, I don't think I realized it was going to be the day after Memorial Day. So if you're like me, getting back in the swing of things, it's been a little slow today. But again, I want to thank you all. I'm going to stop recording now. And